And this one says in the diagram, TE is a tangent to the circle center O. So TE is this one here. And it's a tangent, which means it's just touching the circumference here. And this is the circle. And that is the center O. And AOD is a straight line. AOD is a straight line, which means what is this line equal to? Not in terms of number, but what's another name for that line? If it runs through the center.
Diameter.
It's the diameter, isn't it?
Mm.
So we're just going to, sometimes it helps to just start figuring out the diagram before you even see the question. And arc ED is equal to arc DC. So arc ED is this one here. And it's equal to arc DC, which means these two are equal. So we could draw an arc here and call that E, that's ED. And then TEA or T is 70. So where's T? There's TEA, so that's 70 there. And then they say calculate EAD. So the first thing we're calculating, I'll put it in blue, is E, then A, then D, which is this angle here. Yeah.
Mm.
So what do you think that angle is, EAD? How do we work out EAD?
$70.
You think it's the same as 70? Why do you think it's 70? Why do you think EAD is 70? I think I know which rule you're trying to use, isn't it?
Mm.
There's a rule you're trying to use, but that's not the correct one. Let's look at what we have, okay? We've got 70 here. And what can you say about this angle? Or better still, what is the angle that is formed between a tangent and what line is this? We said this one was radius. I mean, diameter. So this one is a radius, isn't it? You agree it's a radius, and because it's running from here to there, so it's a radius. So what do we know about this angle, which is formed by a radius and a tangent?
An angle formed by a radius and a tangent to a circle, the right angle.
It's a right angle, and it. So if it's a right angle and this is already 70, what angle is that?
20.
20, well done. Because 20 plus 70 is 90, isn't it? 20 plus 70 equals 90. So we know this is 20. What about this line? OE, do you see OE? And OA, what can you say about these two? If this is the center. What can you say about those two lines? What do you think? If you don't know, you just quickly tell me.
Subtended by the same chord.
No, these are the chords, isn't it? These two, this one and this one, they are both radii. This is a radius, this is a radius, which means they are equal. So I can do this. And so if these two are equal, what about these two angles? You see the ones I'm pointing at? This angle and that angle. What are they?
Equal.
They're also equal, isn't it? So we want EAD, which means EAD is 20. You see that? So the answer to the first one is 20 degrees. Then the next one is CAD. And CAD is which one? Let's see. C is here, A is there, and D is there. So they want this angle. What can you say about this angle? If you know what this angle is, you see, we know what this angle is, isn't it? It's 20, and it's subtended by this green line, which I drew here, isn't it? And they say that this is equal to that. So that means this line is also equal, isn't it, to this one? Is it not? So let me put 1, 2, 3, 1, 2, 3. So these two lines should sustain the same angle, isn't it? So if this is 20, this is also what?
20.
20. So you can simply put a 20 there and a 20 there. So the answer to this one is also 20. And now they say angle ABC, which means A, B, and C. So this is the angle they want. How do we find that angle? How big is this angle?
Right angle.
It's a right angle. Why do you think it's a right angle?
Angle is subtended by diameter.
Exactly. So it's because it's subtended by this diameter. That's why it's a right angle. And if this is 20, that's a right angle. What angle is this one? ODC.
70.
70. Well done. So that's 70 degrees because 70 at 20 is at 90 is 180. Okay, what do we know about this angle and that angle? If they are on, you see how they are on opposite sides, this one and this one.
Opposite angles supplementary.
What does that mean?
Means when you add them, they should add up to 180.
Exactly. So they add up to 180. So if this one is 70, what's the other angle?
110.
110. So this angle is 110 degrees. So that's the answer to ABC. Yeah, so we have 20 degrees, 20 degrees, and 110 degrees. Yeah? So that is done. Let's look at this next one, which is in the diagram, PQR, which is PQR is a straight line PQ is 5, QS is 9, and PS is 12. And then they say, given your answer as a common fraction in its lowest terms, find cos of PQS. So cos of PQS basically means PQS means that angle there, isn't it? And then after that, they say find cos of RQS. So RQS is that one there. Okay. So this is RQS, and this is PQS. The little head means that's the angle. So any ideas on how we start this?
No?
Why do you think you've been given cos PQS? Why do you think you've been given cos? Because that's a clue. That's how you're going to work it out.
To find the theta.
Which is angle of Q, isn't it? But why cos in particular? Why not sine or tan?
Because you have the adjacent and the hypotenuse.
Adjacent, hypotenuse, which is the adjacent? Which is the adjacent and which is the hypotenuse?
5 is the adjacent.
It's adjacent to what? What does the word adjacent mean?
Opposite.
Once you can answer these questions, you'll be able to know how to work this out forever, okay? If you can't answer them, it's okay. Just say, I don't know. Then I'll help you. And because I know that they're not easy questions, but I'm asking them because they're important. Okay? So what is the adjacent? You can't say it's the opposite because there's also an opposite side. Okay? So it means that these three things cannot be applied here because they have to do with the right angle triangle. Okay? They have to do with the right angle triangle, and this one is not a right angled triangle. So not a right angled triangle. Because I know that you're thinking of Pythagoras, isn't it? So it's not a right angled triangle. So you cannot use that. Okay? When do we use these three? When we have this. Let me try that again. So when we have a right angled triangle like this one, we can say, let's say this is at the angle theta. So that's the opposite side, and that's the adjacent, and that's the hypotenuse. So the hypotenuse is opposite the right angle. And the opposite side is opposite the angle. Which in case this is the angle, so that's the opposite side. This is the hypotenuse and it's opposite the right angle or the 90 degrees. And then the adjacent, what does the adjacent do? It joins, it's the line joining the angle and the 90 degrees. Do you see that? You see this angle here? And you see the 90 degrees. So this line which is joining them, that's the adjacent side. So this one is not adjacent, the 5, unless if this was a 90-degree triangle. Okay? So we cannot use a squared is equal to b squared plus c squared. We can't use that here. And which in this case would have been h squared is equal to o squared plus a squared. So what can we do? There are two other formulas. There is one called the sine rule, and there's another one called the cosine rule. Okay, so judging by what I have here, I suspect I'm going to have to use the cosine rule. In fact, I know that. Okay, but that's a decision you have to make. So first of all, you got Pythagoras, but you need to make sure it's a right angle triangle. If it's not a right angle triangle, then you want to try the sine rule. Okay, and what does the sine rule say? Do you remember? What does it say?
A over sine A is equals to B over sine A over sine A is equals to B over sine B. It's equals to C over sine B, sine C.
You can also write it the opposite way. You can say sine A over A is equal to sine B over B is equal to sine C over C. You'll get the same outcomes, yeah? What about the cosine rule?
A squared plus B squared minus 2AB.
Is equal to what? So let's start with A. So if you say A squared, I'm going to do A squared is equal to B squared plus
C squared
and then
minus 2BC.
And times what? Times cos of A. So do you see that we have A squared here and cos A? You see that? And then we have B squared, C squared minus 2BC. So the A squared goes with cos A. Okay, so let's draw just a random triangle. And again, this is not a right angle triangle. Yeah. So we can have, let's say this is A, B, and C, right? The angle which is opposite A is angle A, capital letter, and then angle B, capital, and angle C, capital. You see that angle C is opposite side C. You see that? So if we want A squared, let's say we don't know this, but we have C and B and A. So when we have one angle between two sides that we know, then we can use the cosine rule. Okay? But when we have two angles, when we have at least two angles and a side, or two sides and an angle, so two angles plus a side, or two sides plus an angle, we can also use the sine rule. Okay? So in this case, because of this cos here, we're going to use the cosine rule. Now let's look at this triangle. And let me see what color I can use now. I can use black now. Okay, so we're looking for this angle here, right? So if we're looking for that angle, it means we need to make this 12, it's going to be the Q, because that's a big Q, isn't it? Capital Q. So we're going to put a small Q there. Capital P is the angle here. So we're going to put a small P this side. And then this is S. So that's going to be angle S and a small s this side. So what we want this angle, isn't it? P, Q. So we're going to use Q squared. So Q squared is equal to what? We're just following the same rule here, isn't it? Q squared is equal to
P squared plus S squared minus PS
minus 2
cos, minus 2PS cos Q. Cos
exactly.
Q.
Cos Q. But we can call it what they want. They want us to say PQS, isn't it? So we can just say cos P Q with a head, then S, which is the same as cos Q. Okay? So now let's take this, because we want to make cos PQS the subject. So I'm going to copy this so that I put it where there is more space. I'm going to copy this, copy, and then I think I'll open a new, I'll create more space, add a page, and then I want the paper to be squared like that. That's done. Okay, then I'm gonna paste it here. Paste. Okay, there we are. So what do we do next? How do we make this the subject? So make cos PQS the subject of formula. Okay. So what I can do is, because I know this is a minus, that's me thinking ahead. I want to bring it to this side of the equal sign so that it becomes plus 2PS cos PQS, and then I'm going to bring the Q squared and becomes minus Q squared when it crosses over. So 2PS cos of PQS is equal to P squared plus S squared minus Q squared. And then what do I do next? I'm going to divide by
2PS.
2PS, okay. So divide by 2PS on both sides and divide by 2PS. Remember, you're dividing the whole thing. So make sure that you're dividing this whole thing. You can even put it in brackets to be sure. So now that cancels with that, and I'm left with cos of PQS is equal to P squared plus S squared minus Q squared divided by 2PS. Now I can substitute. What is P equal to? What is P equal to?
9.
Small p. P is equal to 9. Let's just put them here. P equals 9. And then S equals 5. And what was the other one? Q equals 12, right? So we just do P squared is what? 81, huh?
81.
Plus 25 minus 144 divided by 2 times 9 times 5. Okay, 81 plus 25 is 106 minus 144 divided by 9 times 5 is 45, so divided by 9. What's 106 minus 144?
Minus 38.
Minus 38 divided by 9. Okay, and we can simplify that to what?
Minus 19 over 45.
Minus 19 over 45. So that's the answer to that one. It looks long because I've made it long because I've been asking you all these questions, isn't it? To make you understand. But once you know what you're supposed to do, okay, you don't have to worry about all these things that we talked about. You just go straight to the formula. And so straight from the formula, you would have been here already. And you'd have done this, and you'd have done this. So within 2-3 minutes, you'd have finished it. And okay, so that one is minus 19 over 45. What about cos RQS? Cos RQS is this one. How do you calculate cos RQS?
R squared is equal to Q squared plus S squared.
Q squared plus S squared. Where did you get 2 squared from?
X squared plus Q squared. Q.
You said S squared plus Q squared. Which Q? This Q? This one? Are you doing Pythagoras again? Well, we have to Pythagoras.
Minus XQ. 2XQ.
2x cubed. Where is the x coming from? You mean S? Which method is that? Is that the cosine rule? Are you trying to follow this again?
Yes.
But if you are doing this here, you need this side, isn't it? And this side and that side, and you don't have this. You don't have RS, so you'd have to do this. Let me put it in orange. You'd have to know what this side this is. Okay? So to find this, you'd need to call this maybe Q2, because this would be Q1, and it's not the same as this Q, isn't it? So you have to know this side, and you don't know what that side is. And you'd have to know, this side, that side. In fact, you don't even know this side either. You don't know what RQ is. So you don't know if we call this one S2 and then this one S1. You don't know what S2 is. Okay? You've only got P, which is that one. So you can't use the cosine rule now. Is that making sense?
Mm.
The cosine rule is now out. But what you know is that this is a straight angle, isn't it?
Mm.
So if this is a straight angle, there's a relationship between this and this. Let's try something on your calculator. Let's say that this PQS angle is, let's say it's 110. Can you do cos 110 and tell me what it is?
Minus 0.3420.
Okay, hang on. My fault. Can you do, yeah, we could actually do that. Let's do cos 100. And I'll write it down. Hang on. Let me do it here with the space. Let's do cos 100.
Minus 0.1736.
Minus 0.17364. Okay. Now, let's do cos 80.
0.17364.
0.17364. What do you notice about these two numbers?
They're the same.
They are the same, isn't it? So I could say cos 100 is equal to minus cos 80. You see that?
Mm-hmm.
Because when these two angles add up to 180, you get, so you could say, you could also do cos 120 is equal to minus cos 60. Let's try that just to be sure. So do cos 120, then we'll do cos 60.
Cos 120 minus 0.5.
And cos 60?
0.5.
So to make it the same, we put a minus, isn't it? Okay. So now we know that the cos of this one, so cos of this angle is equal to minus cos of that angle, isn't it? Okay. So cos PQS is equal to minus cos RQS, which means this is just 19 over 45 because we just put a minus sign there. Make sense?
Yes.
So if we put a minus sign, it's going to cancel out with that minus, so we get a positive. So the answer is a positive. Okay?
Yeah.
Yeah, how to do this one. So it says, huh?
Variation.
Yeah, this one is variation. So given that V varies inversely as the square of t, express V in terms of t and a constant k. And then B, find the value of k given that V equals 25 when t equals 2. And find the given values of t when V equals 1/4. So we need to start with the first sentence, isn't it? Okay. So given that V varies inversely as the square of t, how do we write that down?
The V is equals to K over T squared.
Well done. So that's the
Thank
answer to this first part.
Mm,
Okay. What
yeah.
if it varies directly? What was it going to be?
Values direct. K is V is equals to KT squared.
Well done. So this would have been for direct. But the correct answer is this one. Then it says find the value of K. Okay. Well, that V is equal to 25 when T is equal to 2. So what do you do now?
Substitution.
Okay. So let's say part 1. 25
is equals to K over 2 squared.
and 2 squared is what?
4.
Okay. So basically 25.
I'm going to cross multiply. K is equals to 100.
K is called 100. Well done. So find the value of K. So K equals 100. And then this last one, value of T when V equals 1/4. What do you do now?
The value of T 1/4 is equals to K.
But we know what K is now, isn't it?
100.
What is K? Exactly. So this equation is no longer V equals K over T squared. So instead of V equals K over T squared, it's now V equals 100 over T squared. And
Yes. And then we cross multiply. T squared is equals to 400. Then you square both sides.
You square or you square root?
Square root.
Careful. Okay. So what's square root of 400?
20.
So what's the answer?
T is equals to 20.
Be careful because it says find the values of T. And if you look at here, they say T is this
Plus
or
or
that.
minus. T is equals to plus or minus 20.
Plus 20 or minus 20. Okay, so be careful there because you might lose a mark. So this is plus or minus 20. Okay. Good. I think where we go now, man.
Yeah.
All right. Then this one. In the diagram, OABC is a 120 degree sector of a circle. Center O. So 120 degree sector of a circle, center O, and radius 6. Using your ruler and compass is only construct inside the sector the locus of points equidistant from B and P, and the locus of points 4.5 centimeters from P. Okay. And then it says shade the region inside the sector which contains points which are 4.5 centimeters from P and nearer to P than to B. And then taking pi to be 3.14, calculate the area of sector OABC. So first of all, what, you don't understand it?
I only know part C.
Okay, the calculation. How do you do that?
Theta times pi r squared.
Theta times pi r squared. So what's theta equal to?
Can you move to the diagram?
Yeah.
120 over 360.
Well done.
Times
That's
22
better.
over, yeah,
Yeah.
times 5 squared.
You see why I put a question mark here? Because I was interested to know what you mean by theta.
Mm.
But if you write it like this, then you're right.
Mm.
Okay.
Yes.
So, okay. So that one, we don't need to finish it because that's correct. So let's look at this one. He says use a ruler and a compass. Construct the locus of points equidistant from P and. So what you do is you join them first together, like that. And then you take a compass. You know how a compass looks? Okay. So let's say you suspect this is about the center, isn't it? So when you take your compass, it will be like this. Let me use a different color for the compass. Use red. Right, so you're going to point it here as your compass. So let's say this is the side which is the compass, or which is the metal part. And then you're going to place your pencil here. So let's say this is the side where your pencil is. One. So you want to place it such that it's after this line, after this center point. You see that? So that when you draw like a circle, it's gonna come like this. Let me change the color for the drawing. So let's say gray. So and it's as if you're drawing a circle, so it's gonna come like this. Do you see that? Then you remove this compass, and now you place it on the opposite side at B. Okay, so that what was at P is now at B, and this point is now somewhere here. And then go ahead change it like that, and then you draw another circle. It's gonna come like this. Do you see that? Like you're drawing a circle. So that these points where they meet, you join those two. Okay. But the angle is not straight. I'll try to make it straight because I'm just doing on paper. It should look something like this when it's drawn. Okay, let me remove that and just draw what the correct one should look like. So after you've drawn, the line should come something like this. Okay? Because you're drawing it from there. Okay? Let's make this a right angle. Now, something like that. So that those lines would have come something like this. Rowan. That's called bisecting. Bisecting a line or a straight line. But you can also bisect an angle. Okay? So this is something you just have to practice on actual paper. Or just watch a YouTube video which explains it. Where someone is actually doing it. Okay.
Yeah.
And then they say the locus of points 4.5 centimeters from P. So for 4.5 centimeters from P is easy. You just go to P and you place your you place your compass, not your compass, man. Your protract, not your protract, your compass. And you place your compass at 4.5 centimeters So I didn't get it 4.5. So let's say from P here, let me change to red. From P here, let's say for 4 centimeters. In fact, I'll just pretend, okay, I'm gonna draw a circle like this. And then maybe just move it so that I try to make P in the middle. Okay, so that the radius is about 4.5 centimeters. Do you see that? So you're just drawing around here, but you want what's inside here and the locus of point equidistant from P. So it means that all these points here, or all these points here, are equidistant from P. Okay, now let me make it a bit bigger for a reason like that. So let's say that's 4.5 centimeters. And let's try to make it central like that, so that it's right in the center. You see now? And let's make the diameter go right to the edge. That's the radius, actually. Okay, then it says the locus of points. Then it says shade the region inside the sector which contains the points which are more than 4.5 centimeters from P and nearer to P than B. So if they are nearer to P than B, it means it would have to be, let me change color again, maybe blue. It would have to be these points here. And then Gary, you see this line that we drew here? Remember this line, this one here, the bisector. So they would have to be on this side of the bisector, isn't it? Because that's nearer to P than to A than to B, and it, because that's nearer to P because P is here than to B because B is there, and it. So it would have to be this, but they don't go outside. They shouldn't go outside this. Because they should be within O, A, B, C, whatever, isn't it? So it will be this here, like that. Okay?
Yeah.
That should be it. Okay, this one. The diagram is the velocity time graph of the motion of an object. So always be careful that it's a velocity time graph, not a distance time. Because sometimes you do a distance time graph. It's different from a velocity time graph. When it's velocity time, it's velocity here. When it's distance time, it's distance here. Distance in meters. Okay? Of the motion of an object. Given that the total distance is 1,5, find the deceleration during the first 10 seconds. So given that the total distance traveled is 1,5, okay, it says find the deceleration in the first 10 seconds. Okay, and this is time in seconds, and it says here that it's 20 seconds, isn't it? Which means the first 10 seconds is probably here. So deceleration is happening here. I think it's double C. Okay. So if they say that the total distance is 1,5 kilometers, how does that help you? How does that help? Okay. How do you find the total distance traveled?
Add all the shapes.
Add all the what?
The shapes that you can find.
Okay. So basically you're saying is the area under the graph, huh?
Mm.
If you can find the area under the graph, that means you're finding this shape, area under this shape, this one, and this one. That will give you the 1,5 kilometers. Okay. And because this is meters per second, you might want to change that to 1,500 meters. Okay.
Mm.
But here we're actually given that, what is this on the side? What the diagram actually is not very clear. Is that a 10? That looks like 10, isn't it?
Mm.
And that looks like 60. And
Yeah.
that, so let's assume that is 60. Let me see. Okay. Okay. Yeah, I think that's 60. And this one is 10. So can you tell me something about this deceleration? What's happening? Is it changing? Is it going down? What's happening to the deceleration?
Changing.
How is it changing? Is it getting bigger or smaller?
Big.
Why do you think it's getting bigger? Can you give an example of why you think it's getting big? Using the figures on the graph.
Sixty minus 10 divided by 10 minus 0.
50 minus 10.
60.
Okay, I know what you're doing now. So you're saying 60 minus 10 divided by
10 minus 0.
why do you use 10 minus 0? You didn't answer my question, huh? Let me answer that first and then we move to what you said now. So the deceleration here is constant. Okay, it's not changing, it's not going up, it's not going down. This shows the deceleration that is constant. If it's curving like this, it's changing. If it's curving like this, it's changing, but it's a straight line. What is changing is not the deceleration, it is the velocity from 60 to 10. Do you see that? So velocity is changing from 60 to 10. The time has changed from 0 to 20 because this 10 goes with 20. That's why you can't put a 10 here. You have to put a 20. Do you see that? So even if it's after 10 seconds and because it's constant, after 10 seconds and after 15 and after 20 is the same deceleration. Okay. So what we calculate for 10 seconds is the same as for 20 seconds because it's constant. But if it was changing, for example, let's say that it was like this, then you can say that it's changing. And we would have to draw tangents here. Yellow is not a very good color. I would have to draw a tangent for this one, for this one, for this one. Remember that tangent we drew for that circle, we're doing for that circle, which was like a T You remember it? That's a tangent. So it's only touching the circle at one point. That's what we call a tangent. So these tangents, we're also trying to make them touch because we pretend this is part of a big circle of a radius, which you don't know. Very big. This one, we know the radius, at least, because we know that it's somewhere here. The radius might be there. Okay. But for this one, we don't really know. Okay. So the radius, the center of the circle can be somewhere outside this paper or iPad. And okay, so we use this line to calculate the gradient, and the gradient is equal to the deceleration. So if we're gonna use from 0 to 20, we also use from 10 to 60. So the answer, yes, is gonna be 50 divided by 20, which is 2.5 meters per second squared. That's the deceleration. Okay. Then it says the value of t. How do we calculate the value of t? Any clues?
Use total distance.
Okay, so we can use the total distance now. And so we can say total distance is equal to, the first one can be done as what? Area of a trapezium, which is a plus b. So it's a half a plus b times height for the first part, this one, plus this part is going to be length times width, and then this part is going to be half base times height, and because that's a triangle, that's a rectangle, and that's a trapezium. So trapezium is about parallel sides, and so A and B are the parallel sides. So what is A equal to? And which are the parallel sides? Those two, and so we could say A is 10, and from here to there, that's 10. 10 plus B is the longer parallel side, which is 60, and times the height is what? 20 plus, and then the length is what? Now doing length times width. How long is this?
T.
22t. What do you think is 22t?
20 plus 2t.
Yeah, so if you say 20 plus 2t, do you get 22t? Do you?
22.
Nope. If you say 20 plus 2t and you get 20 plus 2t, you can't change it. Do you understand? It's like saying $20 plus 2 loaves. It's still $20 plus 2 loaves. You can't add loaves and dollars. Is that making sense? Unless if it was 20t plus 2t, then you can say 22t. So basically you leave it like that. You don't change it. Okay? But why are you adding 20 plus 2t? Because
Fine,
remember,
T.
you want, huh?
Fine, T.
No, but how long is this? Not the whole thing, because from here to there, if you say 20 plus 2t, you get this whole thing, Ron. And if you multiply that by 10, then you're finding the area of this. Is that making sense? If you find the area of this, it means you're duplicating because you've already calculated the area of this using the trapezium. And so you can't do this again. If you want to do this, then you have to calculate, you have to add the area of the top triangle. Uruzona.
Mm.
Do you see what I mean, Mish? When you do this, now you're able to do that. But if you've already done this whole thing, you can't do this part again because you're adding something you've already done. Okay? So we're going to ignore this part. To ignore that part. And now if this is 2t and this is 20, how big is this then? We have to remove this guy, Mish. Doesn't that make sense to you? If we've got this length here and it, if from here to there is 2t, okay? It means to get this only, I have to subtract the 20 seconds, isn't it? So it has to be 2t minus 20. Minus the 20. That will give me just this part. And then I multiply that by the width, which is the 10 seconds, plus half times the height is 10. What is the base equal to? What is this equal to? This here. Because I know from here to there is what? 310. What about from here to there? Because I want to remove this. It's 2t, isn't it? From here to 0 is 2t. And from 0 to there is 3t. So to get this, I just said 3t minus 2t. I'll get that. So it's going to be 3t minus 2t. And this is equal to 1,500 meters, because that's the total distance. And now let's simplify. So I'm going to multiply everything by 2 because there's a half there. So this becomes 3,000 is equal to 10 plus 60 is what? 70. And do you see what I mean? This 10, because we already multiplied by 2. So this 2 is gone. It's gone there. Okay, let's rewrite it first. So if I multiply by 2, I'm left with 10 plus 60 times 20 plus 20, because 2 times 10 is 20, and then 2t minus 20, and then plus, this 2 is gone, so I'm left with 10 brackets 3t minus 2t. Okay, now let's do the brackets. So 3,000 equals 10 plus 60, 70 times 20 plus 20, and then 2t minus 20 plus 10, then 3t minus 2t is t. And it, let's multiply further. So 3,000 is equal to 1,400, because 7 times 2 is 14, add the 2 zeros, 1,400 plus, I'm going to multiply inside the bracket now, 40t minus 400 plus 10t. Okay, then I'm going to bring all the numbers to one side. So 3000 minus 1400 minus or plus 400, because 400 becomes a plus. 40 plus 10 is 50t. And what is 3400? What is 3000 minus 1600? The October answer. My brain is funny. I'm giving you the answer already. I was thinking ahead. Okay, so it's 1600 plus 4000 is what? Plus 400 is 2000, isn't it? So 2000 is equal to 50t. So if I divide because they've got, I think they forgot to multiply here. So this cancel, so t is equal to 40. Okay, let's just check in case we made a mistake somewhere. But this one is half a plus b times height, that is correct. And then 2t minus 20 times 10 is correct. And then half times base, this is the height. The base is t, which is correct. Then multiply by 2, get 3000. This remains 20 because that goes. This one doubles to that. And this we still have that plus 10 because that's gone. So that's why I left with 10 there. So this is 3000. This is 70. 70 times 20 is 1400, which is correct there. And then plus 20. 2t minus 20, I leave it there, plus 10t because that becomes a t. And then 3000 equals 1400 plus 40t minus 400, which is that, plus 10t. Then 3000 minus 1400 plus 400 is 50t. So that those two make 50. Then 3400 minus 1400 is 2000 is equal to 50t. So t is 40. Okay. So if t is 40, it means 2 times 40 is 80. So that's 80 seconds. Then 3 times 40 is 120. So that's 120. And then C says the average velocity for the whole journey. How do you find the average velocity?
Total distance or total time.
So what was the total distance? 1500 meters over the total time, 120 seconds. And so that cancels. 12 into 15 is 1. 12 into 30 is 2. 12 into 60, 12 and a half meters per second. So it should be 12 and a half meters per second. Here they got 15. Their answer is wrong. Okay.